using everyday Wi-Fi to keep us safe. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Yingying Chen. She is the professor at the Department of Electrical and Computer Engineering at Rutgers University. Welcome, Yingying.
Thank you. Thank you for having me.
You co-authored a study published in August detailing a method by which common Wi-Fi can easily and efficiently be used to identify weapons, bombs, and explosive chemicals. The peer-reviewed study received a Best Paper Award at the 2018 IEEE Conference on Communications and Network Security. Tell us about the study.
Okay, now our study is that we like to explore a low-cost and deployable method that can help us to perform dangerous object detection inside of the luggage or inside of the backpacks, because we feel that this is a growing need in everywhere, not just in the airport or in the train station. We feel that there's a growing need of the safety concerns and also security issues in the general public. For example, in the entries of sports stadiums, in the entrance of theme parks, and also in many tourist areas such as Times Square, New York City. So we look at, okay, if we can look into Wi-Fi, which is a commonly utilized technology, if we use the fine-grained channel signatures inside of the Wi-Fi, that could help us to determine what is inside of the bag, that would be a very appealing approach or solution to improve the security issues or security concerns people have these days.
What's the theory of operation behind the method? What technology do you use, and how are the results interpreted? How is this different than a metal detector?
Yeah, so what we do is that we look into this, the intrinsics of the Wi-Fi signals. That is, we take out the channel state information, which is a fine-grained signal information from the OFDM. And by looking at that, because for this kind of signals, they behave differently when they bounce on different kinds of objects. They can be reflected, refracted, or absorbed by different materials, and the absorption rates and also the bouncing off and reflection rates are also different if it is metal or it is just clothes or it is like plastics. So the characteristics for the Wi-Fi signals to the different objects, they're different. So we're looking to, by using the signal processing methods, to convert the signals from time domain to frequency domain. And we also utilize machine learning techniques to help us to determine whether there are metals or liquid inside of a backpack.
Are you actually detecting a weapon versus a lump of metal that might be a weapon?
Okay, so currently we cannot differentiate whether it is a real weapon or this is metal, because we're in the academic environment. So we're just doing prototyping. So what we look at is the different kinds of metals, but we do not get a chance to test with real weapons yet.
So that sounds like that's the machine learning. What is the detection accuracy?
The detection accuracy currently is over 95% by looking into, okay, what kind of materials we're detecting, and then after that, if it is liquid, we even want to determine what is the volume of the liquid, and that for that part we can have a higher accuracy, like 96 and 97%.
Where have you tested this method?
We tested the method mostly in our lab at Rutgers University, and also we try to test it in some apartments. But the next step is that we're going to try to test this method in some public areas. So we're trying to talk to the local police department and to see that whether there are any, they show great interest into our work, and we like to see that whether there are any public places we can perform this testing.
So how difficult or easy is it to actually set up screening stations, and how would the screening work exactly?
Okay, so the setup currently it's quite simple. So what we do is that we only need to set up like 2 laptops, one as the transmitter, the other as the receiver. Then it is a portable solution. You can just take it with you, and then we go to a place that we want to do the screening, security screening of this suspicious objects, then we can just go ahead and do it as long as you have Wi-Fi signals around us.
What's the amount of power radiated? Could there be any health implications to some of the segments of population?
Well, it shouldn't be any health concerns because what we utilize is the common Wi-Fi. So we use the general Wi-Fi access points to help us to do this. So we do not generate any additional powers. We only install like 2 additional antennas that we can use to help us to perform the detection more accurately.
What are the next steps for development of this application? What do you have planned for us? I mean, are we going to see this everywhere?
Yeah, we hope we can see this everywhere in a couple of years. Especially, we like to see that whether we can integrate this with the smartphones by making it as a handheld device. Because eventually we like to see that if like everyone, if you download a software that we have and also the algorithms together with it, for example, if I'm waiting for a train in the waiting area, I can just use my smartphone. I can determine whether the passengers or somebody sitting beside me waiting together with me, whether they have any metal objects or dangerous objects, or we see the suspicious objects inside of their backpacks or luggage.
Yingying Chen, Professor, Department of Electrical and Computer Engineering at Rutgers University, working at keeping us safe. Thank you so much for your time. If somebody wants to connect with you, maybe they want to find out more about your work, how can they do that?
Yeah, they can find my email address from my webpage. They can just look for Rutgers and Yingying Chen. You will find my webpage, and then they can look for my phone number and also my email address to contact me.
Thanks again. And if you guys want to find more of my interviews, you can do that right here on ZDNet or Tech Republic, or maybe go to my website, tonyahall.net. I've got links to all my social sites. Thanks for watching.